Good morning, students. So, what we are going to start today is a different topic. Okay. So the topic is based on shear force and bending moments. Okay. So as you all know, we found out the shear force and bending moments beforehand. So now what we can do is I'm just sharing my screen. Can you all see my screen?
No.
Uh, so we will discuss
Now that's visible.
regarding these things. Okay. So first of all, just remember this one things like what are the various parameters that are required to be considered. So first of all, if you see here, there is load, there is shear, and there is moment, right? So what are these three things? So first of all, load. Suppose the load is applied. So the load is applied. So here it is applied in a single point. So this is known as what? This is a point load, right? Now after that, we are having what? The load is uniformly distributed throughout the beam, right? So this is an UDL or uniformly distributed load. Okay, so this is called UDL or uniformly distributed load. Then it comes to what? Uniformly varying load. So this is the uniformly varying load. If you see here, at this end the load is 0 and it goes on eventually increasing, and like at this point, okay, so at this point it is maximum. So this is called uniformly varying load. Now if you go to shear, what is shear force? Now for shear, look, shear force means it is a basic calculation of all the forces that is acting either right or to the left of the structure. So if you can see here, okay, the shear force for this type of loading, this point loadings will be like this, in this manner. Okay, the diagram will be in this manner. Just remember these basic things as of now. After that, for like UDL or uniformly distributed load, what it will be? It will be a linear one. It will coming linearly down. It will be eventually at the point 0 at a point, and then it will become negative here. It's going. So in this manner, it will be changing. Now, for after shear, there is moment, right? So what is for moment? Means after this one for UDL, there is UVL, uniformly varying load. So what is the basic case of uniformly varying load? So in uniformly varying load, we are having it in the form of a parabolic curve. So this is what it is coming in a parabolic manner. Okay. So now after that, finding out the shear forces, what we'll find out is the bending moments. So bending moment means what? The summation of all the moments that is acting either right or left of the structure. Okay, so if it is acting right or left, you have to find out the summation of all these and then eventually find out the bending moment. Now for a point load, the bending moment is somewhat like this. It's 0 at the ends, and at the point where the load is present, it will be having a maximum value. So similarly on the other side also it will be acting in that manner. Now for the next one, that is uniformly distributed load, the bending moment will be a parabolic curve. Got it? So bending moment will be a parabolic curve. So if it is a parabolic curve, then it is what? The bending moment is a parabolic curve. Got it? And for uniformly varying load, it is a cubic curve. Now this parabolic and cubic curve do look same. In the equation, suppose if x square is present, then it is parabolic. and if x cube is present, then it is what? Cubic. This is as simple as that. So this is how you will know whether a graph is parabolic or cubic. Okay. So now we go to the next one. Now look, if you see in the figure for cantilever beams. Now what is a cantilever actually? In previous classes we discussed regarding these cantilevers. What is actually a cantilever? So the cantilever is a type of beam which is fixed at one end, right? You can see here it is fixed at one end. Alright, and the thing is what? It is not having any supports at this end. That means what? It is rather free. So it is free at this end. So this is the difference between a cantilever and a simply supported. So in a cantilever it is having no supports. Now first of all what you have to find out is the shear force. Now for finding out the shear force, what is happening? If you see here, this is the shear force is found out in this manner. Look, there is only one force acting here. So as per definition of shear force, it is the summation of all the forces that is acting either right or the left of the structure. Now here in the right side there is no one, nothing is present, but in the left side only W is present. So if you consider this W, just you have to find like this. This is the whole this W force, so it will be like this in a square manner, the shear force diagram. Okay, since W force is acting only, so it is whole square. Now for finding out the bending moment, how it is find out? Look, force into perpendicular distance is what? Moment, right? Now if you see this force W here, okay, so if it is having perpendicular distance, like it is acting at a distance of L from this point. Now what is happening? We are considering a section here, right? We are considering this X section here. Now in this section it is at a distance of what? It is at a distance of X from W. Now if it is at a distance of X from W, look at this particular point at the tip, what will happen? W, the X will be what? Into 0. That is why it is 0 here. Now eventually, since the length is increasing, therefore the moment will also increase. Now at this section X, suppose at this section X, what will happen? W into X, that means what? Wx. So the moment will be here, W into X, like this. Now again it is increasing like this up to the end. Now at the end what is happening? The length is given, the total length, that is L. That is why we are getting this W into L. I hope this is clear for everyone. This things is just the explanation how to find out. So you can have a look at it, and this you will find out that this is how we have been finding out. Now if you see here, if you see this diagram, in shear force what happens? Look, this side is coming down and the section is to the left, right? Now here also what is happening? This is coming down and the section is towards the left. That is why the SF shear force is positive. Okay, now after that what happens? Here, if you see here for the bending moment, okay, if you see here, now because of the application of the force in the cantilever beam, what will happen? Here you are applying some force, but this side is what? This is fixed, right? If it is fixed, then what will happen? This part will remain same, but here it will what? Bend. So so this is how it is coming, right? So if this is like this is bending in this manner because of the application of this load W, then this will look like this. So we are considering the bending moment to be what? Negative. If you see the negative sign here. Okay, so this is how it is being done. I guess this is clear for every one of you. Just have a look at it and you can ask me for any doubts. If it is clear, then you can move to the next unit. Is it clear for everyone? Is it clear for everyone?
Yes.
Yeah, I'm not hearing you. Can you please be more clear? I'm not being able to hear. Hello?
Hello.
Hello? हाँ सुन रहा बोलो.
Hello.
Hello?
Hi, sir. Hall. Yeah, hall, sir.
Amarjit, right?
Hi, sir. Hi, sir.
Yeah, please speak up. Yeah, please say. I can hear you. You have any doubt? So can you please explain it again? John Kerry. Okay, I'll explain this again. Which one? Which one you need, John Kerry? Which part do you need to be explained again, John?
The PM diagram.
Bending moment thing.
Yes, sir.
Okay, just a minute. So look at this. Now the bending moment will be negative. Why it is negative? Because the right portion of the beam section. Now for finding out the bending moment, remember one thing. We are considering one section XX here. One section XX here. Okay. So if you are considering one section XX here, then what happens? Okay. Here this load is applied here, right? Now the movement of this load is clockwise, or since this is clockwise or since this is coming down, if you see here, look, this one, if you see this part, now the section is considered here, now the section is considered here. Now the load is here, so it is coming down, because of this load. What will happen? Suppose this is the beam, so it will be bending like this. This is just the example of a scale. If you take a scale, long scale, and if you press it one end, the one end is fixed with your hand, the other end will come down, na? Just think of that. You take one long scale in your table, and what you do is you just put your hand on the edge of the scale and press it down. Then eventually it will come, but it will be giving some bending, right? It will bend in that manner, and for that case the sign convention is what? Negative. That is why we are considering the bending moment as negative. Now I explained in the previous classes regarding moments. So what is a moment actually? Moment means what? Force force multiplied by perpendicular distance. Now look, the force acting here is what? W, and the distance is what? L. So for finding out the bending moment, you have to just consider one section here, XX. Okay. So if you consider the section XX here, then what will happen? It is at a distance of X. So if it is at a distance of X from this W, then W into X will give you the bending moment at this point. Now if you put this section and pull it to here, then what will happen? X is equal to 0. So if it is 0, then obviously the bending moment will be 0. Now you take this section to here, like here, in this manner. So then what will happen? It will be at a distance of X. That is why we got W into X here, like this. Now if you take this section here, so it is coming to a distance of what? L. If it is L, then bending moment Bm will be what? W into L. Simple. If it is W into L, then you got it here. Now why negative? I just told you right now. So this is how it will be there. Okay. Now I guess you understood, John. Did you understand, John?
Yes, sir. Thank you.
Okay, good. Anyone else? Anything else regarding this topic? Anyone else is having any doubts or problems regarding this? If not, I'll move to the next unit.
No, sir. No.
Okay, fine.
You can, sir.
Yeah. Okay. Someone, I asked Temazad, no, you to collect the answers. Did anyone give you the answers of that numerical?
No, sir. You give time till Sunday, sir.
Yeah, I gave
That's
time. Someone messaged me, said that they've got the answer. Like, I guess Ansari. Ansari, why don't you do one thing? I have asked Temazad to collect the answers. So you give him the this one, your answers
so
and give it.
I will ask them and ask them to write their name
Yeah, yeah, yeah. Ask them to write their name. Click a picture of it, and you just
and
make one
I will.
PDF, okay? And then send it to me.
Okay, okay, sir.
Then it will be better for me to evaluate also.
When time will come, sir.
Yeah, when time will come, obviously. Okay. Answer is there,
Okay.
but he is not responding. I guess he's not. He is just present. I don't know. Fine. You just do that thing. Okay. So what I'll go to the next topic now. So are you understanding what I'm saying till now? beforehand also, before those also.
You can start next topic, sir.
Yeah, that's what is better. I guess no one has got any doubt. Let me start the next topic. So, can you see the screen? Can you see the screen?
Sir.
No?
No.
No.
Wait. Okay, now? Can you see the screen now?
Yes, sir.
Okay,
Yes.
Centroid.
thank you. So, what is centroid and center of gravity? Now, the term centroid and center of gravity. Have you heard of the term before? Have you heard of the term centroid before? Now, centroid can be defined as the arithmetic mean or the center point of any two-dimensional figure. Okay. Now, if you see this figure here, now this is a rectangle, right? This is a rectangle, right? So if you, this is a rectangle, in this rectangle, what happens? If you draw one diagonal from this side to this side, the other diagonal from this side to this side, then all these diagonal what they meets at one particular point. Now that point is known as the centroid. Just remember one thing, that it can be defined as the arithmetic mean or average of all the points on the plane figure. That means basically it is the central point of a plane figure. Now look, for triangle or for rectangle, it is simple. You just put the diagonals like this, and the point where it meets, this is known as the centroid. But for a triangle, it is a bit different. Now this is a triangle. Triangle is having three sides, right? Now if the triangle is having three sides, then you have to do one thing. You have to just simply pull it, draw the meridian from the one edge of the triangle to one center point of the other side. So similarly, in this manner, you have to draw all the three, and then point at which this all meets is known as the centroid. Now, can you say me the centroid of a circle? How will you locate the centroid of a circle? Can anyone say me? Can anyone say me? Can anyone say me what is, how will you locate the centroid of a circle? Just say me in a basic way.
The radius.
Okay, very good.
If we divide the diameter into part, that
Okay,
portion will be.
okay. So that means what? You are drawing a circle with the help of a what? Compass, right? You use a compass to draw the circle. So now if you use the compass to draw the circle, then what will happen? The center point on which you place the tip of the needle. That means the tip of the needle of the compass is being placed at the paper. Now that from that point only the rotation starts. So that tip will be the what? Centroid. As simple as that, in simple manners. Okay, so this is how we draw a centroid. Now coming to the next one, I'll explain it a bit more in this regard. Now, what is center of gravity actually? Now, center of gravity of a body is the point or the center through which the resultant of the distributed gravity force passes. That means what? In the center of gravity, suppose the distributed forces or the resultant forces that are present, they are acting from one point, right? Like when you see for an object, like while calculating center of diameter. So like from calculating this one, suppose this is a rectangle. In analyzing, we just made one like this, no? X gravity is coming downwards or something like that. So this point generally is assumed from center of gravity. That means the point from where is a center point of a mass or a body from which the gravitational force are assumed to act. That means it is the point from which the gravitational forces are assumed to act. That is known as what? Center of gravity or CG. Just remember that thing. So here, as per the definition, the center of gravity of a material body is the point through which the resultant of the distributed gravity forces passes, irrespective of the orientation of the body in the space. The center of gravity is a term which is applicable. It is applicable for bodies having the property of weight. Okay. It can also be stated as the point through which the whole weight of the body is acting. Like suppose there is one solid object. Now if you see in that solid object what happens, the whole weight of the body, whole weight of the solid body is acting through one particular point. That point you can say that it is the center of gravity or CG. Okay, so this is how we define. Now if you go to here, now first of all, how will you find out the center of gravity? The center of gravity can be found out by geometrical considerations, number 2 by moment and number 3 graphical. Now how will you find out? First of all, by geometrical considerations. Look, if you have to find out center of gravity by geometrical considerations, then how will you do it? Now, like for a uniform rectangular figure, it will be what? It will be at its middle point. You have to remember certain form, like certain expressions we found out. So for a uniform rod, it is at its middle point. Or for a square, let's draw a square. I guess this is, yeah. So this is a square, right? So this is a square. So you have to find out what? You have to simply like find out the center of gravity. How will you find out the middle point? Like here, maybe you have to draw the diagonals. 1, 2, 3. So you have to simply draw the diagonals here like this. I'm just and the other diagonal in this manner. So the point at which these diagonals join, actually, this is called as a centroid or center of gravity. Now for a uniform rod means, suppose there's one cylindrical rod like this. So it is at its middle point. That means what? At the middle point, we will consider the gravitational forces to act. So this is what. Now coming to a rectangle. So for a rectangle, what happens? I just discussed it right now. It is the point where all the diagonals meet each other. Look, this is the diagonal, this is the diagonal. So at point G, all the diagonals are meeting. So now, if you have to find out the center of gravity, there will be in two directions. Suppose in one direction it will be L by 2. Why L by 2? Because the length is L, and in the other direction it will be H by 2. Why? Because it is H. As simple as that. Now, for a triangle, I just discussed it a few minutes back. So for a triangle, it is a bit different. Okay. So what happens in the case of a triangle? So in the case of a triangle, you have to draw a median. Median means what? A median is a line which is connecting the vertex and the middle point of the opposite side. Now look, this is the vertex, right? You know, this is the edge of a triangle, so it is known as a vertex. Now if it is a vertex, then what happens? This vertex, if this line we are drawing and it is connecting the midpoint of the opposite side, like this point D, for this side BC, this is the midpoint and A is the vertex. So we are drawing a line like this. So similarly from the other two vertex, that means the B is a vertex and C is a vertex, right? So if we are to draw a line from vertex B, we will be drawing from B and goes on, and then in AC it is E. So this center point, and similarly in the other side, this is F. So this is the center point. So like that, what happens? These 2 points, or it is the vertex on the middle point on the opposite side of the triangle. So in this way, the center point at which all these three vertices meet, this is called the center of gravity of the triangle. Okay. Now, for finding out the center of gravity of trapezium, there is one particular formula. So this is the formula that is to be used. What you can do is you can just take a screenshot of this part. Yeah. If it is when it is done, just tell me. You can take a screenshot of this part. Have you taken this, students?
Yes.
Done.
Yeah. So you can do one thing. If you have taken it, you can circulate in your class group so that your friends can get it, right? And yeah, that's it. And then we'll go to the next one. The center of gravity of a trapezium. So here, these are the formulas that it will measure, means remembered. So this is the center of gravity of a trapezium. This is a trapezium, right? So this is a trapezium. So in this way, we will find out the center of gravity of a trapezium. Now for a semicircle. In a semicircle, what happens? Semicircle means this is not a complete circle, but this is a half circle. Now in a semicircle, what happens? In a semicircle, the center of gravity lies at this distance 4r by 3 pi from its base. Now this is the base of the semicircle, right? Now this is the distance 4r by 3 pi. So now from this distance only, this G, that means center of gravity of this semicircle lies. This is what is known as the center of gravity of semicircle. So you have to find out, remember these things. Huh? Then you go for the other ones. Like the next one is what? The center of gravity of a circular section making a semi-vertical angle alpha. So this is what? This is a circular section. Like this is a circle. So this is the point. Now if you cut like this, so this is a slice of a pizza like thing, right? So it looks like this part. So if it is a this slice, you take it out. Okay, this pizza slice, though it is not actually pizza, so it looks like a pizza. So I'm giving an example. So the center of gravity of this sector, or remember this slice of pizza technically is called a circular sector. Now the center of gravity is given by this expression. The center of gravity is given by this expression. Okay, just remember it. This expression is used for giving this the section of center of gravity of a circular sector. Then you go to what? Cube. Now for a cube, the center of gravity. Cube means what? The three-dimensional version of a square, right? Suppose this is like this. We draw it in this manner, right? We draw it in this manner. So this is what the cube is, right? So this is what the cube is. So the center of gravity of this is a distance of L by 2 from every face, where L is the length of each side. So this is what the center of gravity of a cube. Now for a sphere, sphere means what? It is not a circle. It is a ball. Now you have seen all kind of balls, football and cricket ball. Now for finding out the center of gravity of that kind of figure, it will be what? It is at a distance of d by 2. Like d is the diameter of the sphere. Someone said just now. So if you divide that by 2, then the center of gravity will be that distance. That means what? It is r, or r equal to what? D by 2. Now if you see, this is a hemisphere. Just don't confuse with these two. Beforehand it was a semicircle. Semicircle means half circle, and hemisphere is a different thing. Okay, so hemisphere means what? It is a what? If you cut the ball into half, then it will look like this, no? Like this. So this is a hemisphere. So the difference between semicircle and hemisphere is like this. So the center of gravity of a hemisphere is 3r by 8. So in semicircle it was 4r by 3 pi, and here it is 3r by 8. These are certain small differences. Okay, so this is how we find out semicircle of a hemisphere. If you want, you can take a screenshot of this part, then I'll go to the next one. Take a screenshot if you want it. I'm just drawing it out. Now I guess it is better. Now I think so it is better. Have you taken the screenshot of this part? Have you taken the screenshot?
Sir.
Okay. You just circulate it in your class group, okay? Now we can take
Sir.
for this part also. Yeah. Take for this part also and just tell me. So these are the important expressions that you are actually required to remember. Okay. Is it done? Is it
Yes,
done?
sir.
Okay. So, so in today's part, do you have any doubts? Any one of you? Do you have any doubts? Anyone? I guess no. Okay, fine. It's good.
Sure.